Thank you for having me today to share some of the research and technology development experience in Huawei, try to solve some real system problems. So my presentation is about using AI, aka actually machine learning, in cloudified core network operations. So actually, Patrick's opening speech just summarized a few good points in terms of applying machine learning AI in telco systems. I can't agree more on the points Patrick just made. So in fact, the first couple of slides in my slide deck also try to emphasize the need to rethink of leverage the latest technology in the cloudified core network. As we all know, the telco system is evolving from the traditional physical server-based systems to a cloudified system. And we've seen in OTT systems, we've seen companies like Netflix or Facebook, they have been leveraging the latest technology and achieve very efficient operation and management experience. So how do we leverage these technologies also in our operations after we cloudified? So let's look at the main challenges we are experiencing once we start to redesign or evolve our telco system to a cloud-based system. So not only we are having more KPIs or metrics to monitor, like for example, the VoLTE by itself is already complicated. So we have 30,000 plus KPIs now in a typical microservice / container-based system. We're talking about 100,000 metrics or KPIs. So really the operation and management complexity increased while we're gaining some of the agility or efficiency by leveraging the latest technology. We are actually experiencing much worse OM situations. And second, with horizontal layered system or services now, we found lots of issues. They actually have indications, but in a traditional telco system, we usually use the alarms, which reflect the critical KPIs. But sometimes when things go so wrong, which will eventually reflected in the critical KPIs, there are indications already. So we're looking for ways to find silent fault early on to help us to prevent or help us to speed up the anomaly detection. And last, we're talking about, the new technology should enable us to do zero-touch system. And we want to have self-healing capability, and we want to do the fast recovery. So these are the challenges or hopes we have when we try to move to the cloudified system. So to highlight what I was just mentioned, those challenges, here's an example. This is a real-world use case, a problem noticed after a HSS upgrade. So after the upgrade itself introduced a small failure at time 0. So this is time 0 when the failure actually happened. But at that time, because it's late at night, typical telco, maintenance window, and then the traffic is very low. And at that time, the affected subscribers probably is at the range of 100. But this hidden problem didn't hit the critical KPIs till after 5 hours. So even though after 5 hours the failure was identified and immediate, data collection and analysis actions took place, it still took around 4+ hours to fully recover the service. Why? Because at this time, the number of subscribers already reached, close to 8,000. So we're talking about to fix 100 subscriber error in the database compared to 8,000. So, and this actually is a typical case when we introduced a few small errors here at time 0, which eventually, because it's not surfaced and to be identified quickly, we're experiencing much worse service impact. So how to detect the silent fault early on? We carefully examined a lot of similar cases of the silent fault. It's not just about the fault introduced by upgrade. That's just a typical case. But even during normal operation, there are many cases where the silent faults happen. So we found actually by applying these 3 pieces, which is one is a dynamic threshold, the second is the all metrics monitoring and distance calculation, and the third is to perform the RCA combined with domain knowledge, and here specifically refer to the decision trees and correlations. So here is a brief of what we're doing. So in a typical telco OM situation, so if there's a failure happened, there's a phase we do anomaly detection, and there's a phase to do the RCA root cause analysis. So our approach is we will apply machine learning to all metrics in this phase without assuming any domain knowledge. And then we will do the RCA combined with the result from the anomaly detection and also the domain knowledge. And why in this way? Because we've noticed if we apply domain knowledge early on at this phase, oftentimes we miss some metrics which hadn't got into the critical KPI yet. Especially there are also cases where some metrics only affect a certain small features, like say, for example, some call features only certain subscriber groups subscribed, and unfortunately, sometimes those advanced call features are used by our VIP clients. So here we want to do the generic all metrics anomaly detection, and here once we have the detection, we want to start to use the correlation based on the domain knowledge and also the decision trees developed out of the domain knowledge. So here I want to talk a little bit about how to accurately detect anomaly. I think everybody probably knows we are moving away from the fixed threshold to the dynamic threshold. So that's sorry, there's a typo here. So because of the nature of the telco telco system operations, a lot of KPIs, they actually have periodic ups and downs. So, but even if we do a dynamic threshold, like say, for example, before we actually run the anomaly detection, we run the algorithm learning for 30 minutes to a couple of hours, so we learned. But still, there are cases where this method won't work. Here are some typical cases. One is if there is a trend. So basically, your moving average actually moves not on top of the periodic phases. And second, there are cases where there are spikes, and then this method won't work either. And another case where is the problem is with this dynamic threshold individually. So basically, we learn every matrix threshold, which is computing intensive, but also it creates lots of siloed data in the threshold. We're also trying to solve this problem by using one model to cover more KPI threshold curves. So this I put this here just to give you some idea of the anomaly detection dynamic threshold. It's a very good idea on the surface, but it's not that easy to implement a very effective one, especially when you try to decide whether there is a problem in the system. So with all these in mind, we're looking into the OTT or industry, see what others are doing. So here I just listed a few algorithms from OTT companies, like say, for example, the robust PCA, the Netflix is widely using this. And then these are the additional machine learning method. And here, some companies are doing even more advanced ways of doing that. Like these are still the machine learning, and discrete wavenet transformer is more like something like you do it's similar to the time domain and the frequent domain conversion. And some goes even further to use the RNN LSTM, although we found actually it's very challenging to use a neural network here yet for the KPIs. So with all these methods in mind, we're trying to figure out what's the best way to do a more accurate anomaly detection. So eventually, through some of the tests and research, we found also we actually tried to learn ways from some of the algorithms. So here's our approach for the anomaly detection. So we are trying to use a multi-model detection. So each pass, we will apply one algorithm, because sometimes one algorithm or model is not good enough to give us an accurate result. So we will do multi-model detection, and then we'll apply weights. And then all these applied will calculate and give a vote, and this will give us a recommendation whether it's anomaly or not. So this is if some of you are familiar with the image processing, so this is very similar to the linear classification method. So by doing this, we can adapt to various KPI distribution models, and through learning the weight, we can fully automate this process and improve the robustness and noise reduction. So here is a replay on a error case experienced using this technology. So here you can see this is also a case where after the upgrade, this time it's not HSS, this is a CSCF upgrade. So if you look at here, this particular KPI or matrix actually has a much bigger distance than others. So we identify this as a error or anomaly. Now, then about RCA. So once you identify the anomalies, you have a set of metrics or KPIs which indicate there are some issues there, but which one is causing the problem, or more accurately, so what should we do to recover the service, right? So this is a typical RCA process. Here we found actually to apply domain knowledge will give us a much quicker result. So here we do the correlation. Typically we use the Pearson correlation here, and also combined with the decision tree. For this decision tree development, we use both the forward decision tree based on the system design, and also the backward decision tree based on the real errors. So combine all these together, we can identify the RCA much quicker. So this is another case to show how this RCA is performed. Say, for example, this is a case where we found IMS call success rate dropped. So from the KPI data, we see issues here. So this part is the anomaly detection part. And then once we have the anomaly detected, we will pass this through the decision tree here, and here it'll go to the correlation analysis, and this will give us the top ends for RCA recommendations. So what are the top ends? And then combined with some of the results here, we can narrow down much quicker on the RCA. So, so I just gave a very brief on what we have done in terms of research and technology development here. Those are more algorithm or model related. So as any system, there are always two pieces. One is you need to have a platform, and second would be the algorithm I just mentioned earlier. So Huawei has been developing this Softcom 2.0 analytics platform, which will enable us to develop more algorithms based of our core network systems debugging. So this is the foundation for the analytics. So in the past, it's all batch processing, but now we really need to do the real-time anomaly detection, which means the data we need to support streaming data here. So this is all the work the Softcom 2.0 is doing, and we will continue to develop our algorithm on top of that. And here are the three phases we are planning for our OM, at least with regard to the error detection. Yeah. So I think I'm running out of time. So here's the key takeaways. Basically, I think we want to emphasize that we want to leverage the machine learning technology in the anomaly detection and also combine the domain knowledge in the RCA. We do not want to go to one way, only one way. So combination of these things, we found it would be the most effective and efficient way for us to improve our OM performance. I think I'm right on time. Thank you, everyone. If you have any questions, feel free to reach to me. I know I just gave a very brief technical presentation, A lot of people probably have lots of questions. Feel free to reach me to discuss. Thank you.